Hello, everyone, the GUADEC community and the world. Welcome to my talk, AI Navigating the Chaos, and three crazy cats. So I'll start with who am I. I am a long-term contributor to the GNOME project. I work on community management and advocacy. A lot I learned at GNOME. And I work for Intel Corporation as a senior community manager for One API for heterogeneous computing on GPUs. And I also work as an event planner and a program manager for developer outreach programs. So I can't do an AI without at least some reference to the matrix. And so, but I'm not here to really say you should use AI or whatever, but it's more of a talk to kind of get people up to speed. What is AI, what it's used for, how does it put together, that kind of thing. So it's really more about how do we position the project, right? And the idea, let's brainstorm how can we harness AI equitably and responsibly within the GNOME ecosystem. But before we do that, let's see what the world of AI looks today. And I'm going to say a disclaimer, I'm no AI expert. I'm learning just like you, and also my opinions are my own, not my employer's. So this is what AI looks like in a germ flow. So you have a general view of AI, which is artificial intelligence, which is dependent on machine learning. And machine learning has been with us for many decades, many, many decades. And there's a sub-ecosystem called deep learning. And this is where a lot of things has been happening in the last 10, 11 years, right? And within the deep learning, and deep learning is really using, probabilities and I'm trying to get the name of the word I wanted to, but it's neurons, right? It's artificial neurons and then finally LLMs, large language models, are the even closer where you apply deep learning to that's the thing with generative AI and so forth, right? So when you're thinking about deep learning, there's two kinds. There's supervised and unsupervised. And if you look in this graph, you can see these deep learning algorithms have, the supervised training has things like labeled data sets. Like think of marketing data or sales data, that kind of things, right? It's classified, you know what it is, and you know what the output is. Then the unsupervised training is, this is about patterns, right? You don't really know what the data is. Think of like videos or things like PDF documents. You don't really know what the data is, but you kind of keep training it until it starts figuring out patterns, and then it figures out what it is, right? So when you're trying to teach through training, you first start with, okay, I recognize a line, or I recognize a triangle, and I recognize a dot, right? And then you keep training, and then it starts saying, oh, I can recognize a face, or I can recognize this animal, you know? And so it just kind of, but you need lots and lots of data to make that happen. And then there's reinforcements training, where it's like, you say, oh, is this right? Yes, it is. Okay, I'm doing the right thing. Is this right? Yep, I'm doing the right thing. So it kind of trains through reinforcement. And then deep learning, the word I finally was looking for is neural networks. And that's the deep learning part where you're mimicking how a brain looks at patterns, right? We're using neurons, artificial neurons, which are essentially using mathematic models for that. So unsupervised, again, I'm sort of repeating myself, is basically creating predictive models using neural networks to parse and recognize patterns. And if you nail it down to one word, it's just predictive modeling. It's just guessing with high probabilities. And then comes the large language models. And this is the big thing behind ChatGPT, Copilot, all these things that you see that everybody's making a big deal of. It's large language models. And this is exactly where they're using the neural networks and try to figure out how to generate something based on a prompt. So you do all these prompts, and then it runs it through the large language model, and then does something. So you can kind of see this, right? So in this graph, you see web data, source code, images, structural data. I have something called RAG, which is, they call this, sometimes when AI does something, they call it an AI hallucination. And it's when you say something and it's completely wrong. Like, are you hallucinating? What is this, right? And RAG says, okay, this thing is out, and I'm going to kind of go out into the web and find the data, that's correct data, and then use that to train and fix myself, right? So that's what, and that RAG is relatively new in the last 6 months or so. And there's already a nonprofit around called OPEA. That's a whole bunch of companies are working on RAG. And unfortunately, I didn't tell you what RAG means, because now I've forgotten it. So I will tell you later in the chat. And so if you go through these large language models, you see it can do grammar checking, it can do the generative AI people know, it can do medical analysis, because again, if you're looking at a medical chart, let's say you're looking for anomalies, so finding anomalies better than humans can, because again, it's pattern matching. And so if you think like, well, doesn't match the right pattern that I see in a normal, what is normal, right? And so point that out, right? Same thing, self-driving cars, or translating from one language to another, so forth, right? So these are things there. And I have this little picture of knobs, and you can train these LLMs with lots and lots of knobs, with thousands of knobs, and each one of them is adjusting the behavior of the LLM. So there's a lot of parameters that you could change. They call it hyperparameters and so forth, right? So the industry is gone, we really want to do this, right? Because they see all kinds of possibilities. So they're buying data they can get their hands on. And trying to find new ways to use LLMs. There's all these research going on, and they're trying to find new ways to solve old problems, which we kind of seem to be doing that every generation. We have new technologies, and we're still trying to try to solve the same old problems. But ultimately, again, as I was going back, what is the essence of AI? And it's just a mechanism to discover patterns. And every time, if you're taking a generative AI, say, write a sentence about this, right? Every time it's going through it, it actually breaks down into little components, and it just says, what is the probability that the next component is this? Well, based on all this data I've been trained on, there's a high probability it's this. And it keeps doing that until it comes out with a sentence, right? But it's taking all this human human works to do that. I like to call it Mad Libs for some people who don't know what Mad Libs are. When I was a kid, to keep me quiet on a road trip, they would give me Mad Libs. And then you have a story. And then they'll have a fill in the blank adjectives, noun, verb, and then we kids will be putting in some absurd verb or absurd noun, and then it comes out with this funny story, right? And that's what Mad Libs is, and for those who don't know. But we talk about training, but that's only one part of AI. Like you're feeding this, but then how do you tell it's correct? Right? And that's where inferencing comes in. Inferencing tests the correctness of an LLM and keeps using real data. And it says, like, hey, did you really get the right response? Did you get the right response? I don't know. And so you use this, it's QA, right? You always QA something. And so that's what inferencing is. And interesting enough, inferencing, more than LLMs, has both a high carbon impact and compute impact. And what is that? It takes millions, hundreds of millions. OpenAI spent, I think on GPT-4, spent $100 million to train one LLM models. How many LLM models are there? Just imagine. And it takes $1 million to train them, and that comes through the compute. There's like thousands of GPUs in a cluster to do it, right? And we're talking GPUs of various types. And then the carbon emissions are insane. So think about one LLM is 125 round trips between New York and Beijing. And that's just one. So there's 54 of these LLMs and growing. So you can imagine that the cost of AI is fairly high for people. By and large, so the tool chain to train in AI is largely open source. And I left to TensorFlow and PyTorch are two such ones that are super popular and being used all the time. And for open source LLMs, we have, of course, Meta has Llama, and Bloom is another one for Hugging Face, and then BERT by Google. And Microsoft has one. So everybody probably has some kind. OpenAI had their older ones had a open source license, but the new one is more proprietary. So it's generally been that. But then if you look at it, you still need, even if the tool chain is open source, it still takes hundreds of millions of dollars to do things. But the interesting bit is you can do that training by Microt Training. Thank you. 10 minutes left. Okay, so I'm going to go faster now. So open source inferencing is OpenVINO, OpenPL, Translate are a bunch of stuff that does open inferencing. Intel manages the OpenVINO project. It's one of those things. What's the debate going on in open source and AI? The OSI's position is this is really unprecedented. And the questions they're kind of asking is about data and certification, right? So how do you determine if a system is certified open source AI, and then what constitutes data in an AI environment, right? Like how do you identify what goes into an AI or LLM? And so the debate is they have a draft, and they've been doing a roadshow, going to various places, and they're focusing on the code. And the four freedoms, but not necessarily the data. Now, there are others who said, well, how can you only focus on the code when an LLM or an AI is nothing without the data? So this whole thing is there's this huge debate going on, like how do you classify that data? What's in it? Think of it in ingredients, right? Because you don't know there's probably definitely AI who's using sketchy data, right? And that data is going to be bad because if you're trying to understand what's the training data is, the global South communities cannot build, like in terms of its accessibility, they can't do their programs on their own. They can't afford to pay OpenAI. But for them to participate in this, and we need that because again, sketch data, right? I'll give you an example. If I type in an Indian man walking down the street, almost 99% of the time, it's going to be a guy with a beard, a turban, and some kind of religious thing on every time. I can never get it to do anything else. This is what AI thinks Indian people are, right? It's this very narrow thing. And so this is why it's important that global South communities participate, because they don't have any idea of our languages. They don't have any idea about anything. And so, we need to be able to self-correct. So we also need to know how the data is analyzed, where it's coming from. There was a recent one that was trained on child sexual abuse images, right? So these are like crazy stuff that we need to figure out, and that's where this debate comes in. Ethical concerns, harvesting the data against the will of the creators, training on dubious data that might perpetuate racial, class, cultural, religious, gender injustices, climate and carbon footprint, the politicization, fraud, criminality, identity theft, propaganda. The amount of turbulence that we're going to get through AI, we need policies and we need them now. And there's still a whole bunch of hype on AI. And Goldman Sachs says it's like $200 billion is invested in AI. But I've been told that the bottom has finally, and there's going to be a course correction. Hardware. By December, we're going to see AI PCs. And they're going to have NPUs, neural processing networks, so they're the ones that are going to handle that math of neurons, and so they can offload it. Intel has Lunar Lake in laptops to speed that. AMD has Ryzen with XDNA drivers and so forth. Okay, so we're trying to get back to GNOME. GNOME and the Foundation, I think it's important that we take a political position on AI. It's a position statement so that we're working with the FSF, Software Freedom Conservancy on where we stand simply as from an ethics point of view. And we have to be with our partners because I think it's important to know where we stand because AI represents so many things. So that's one of the things I think is important, especially if we're talking about diversity, equity, inclusion, and things like that. We want to say we care about the data that comes in. This is an important part of it, and that's why we want to make that political statement. Leveraging AI today, what makes sense, right? One idea is maybe to use AI to help ease code maintainership. One of the problems where headaches we're going to get is the upcoming generations are going to be used to using generative AI to at least start with code, let's sample code. So what happens if the AI is generating the wrong code? And now they come in and then they like, hey, why is this thing not working? Well, you're doing it all wrong. This is absolutely wrong. So it's almost like we need to get ahead of it in a way to make sure that they're being trained on each release. And so that's something that might be problematic as in the future for younger developers coming there. The other one is, you can train on issues. How can we ease maintainership? There's lots of ways to do this. Training on our documentation. A lot of times I've used this, I've used for Python to generate. I wrote a thing that hooks up to pulse audio or Pipewire, and then recording it into a WAV file, and then running it to a Whisper LLM, and then I get a thing out of what was said in voice, right, on text. But I use generative AI because I have no idea how it started. But it was a great way to know how to use Pipewire. Anyway, the call for actions is try out these large language models. You can run them on your laptop today. There is an app on FlatHub called Alpaca, and the great thing is you're not going onto the web. It is all the generative data is running on your laptop only. So it downloads the LLM model, and then it's already trained, right? So it's just generating stuff. So you can do prompt engineering on that. So then if you want to look for new models, the AI community has a GitHub-like place called Hugging Face. That's all I have today. It's my glad to hear your thought. Is there any questions? Anybody on the chat can? What?
We have asked if they have any questions.
Okay, great. Did I get it under time?
Okay.
Huh?
Nailed it. You got two whole minutes here.
It's still 12:25, right? Sorry, 14:25.
2:20 is the after break.
Up to 20. Okay. Yeah, we can wait for a few minutes if we have any questions.
Okay.
Yeah.
I ran all the way back here from where we had lunch. I left my phone there. And Arthi had called them up. They got the phone and kept it for me. So it was like I got here just like right before this talk
Yeah.
after running, and luckily I was just thinking, oh, is it gonna rain?
Yeah.
Can I get there and back before that? Yeah, it just started.
Yeah.
Now it's done
Yeah.
until the next storm. There's nothing mild out of Denver. It's always over the top. If it's gonna hail, it's gonna hail like crazy. If it's gonna rain, it's gonna rain like crazy. If it's gonna snow, that will happen in June. You'll be shoveling snow, and then within a few hours later, it'll be 100 degrees. 100 degrees.
I don't think we have any questions as of now. So
Okay, great.
maybe-
Well, they know where to find me.
Yeah.
Y'all know where to find
Yes.
me. So
Yeah.
hit me up later if you're all shy about asking questions. Thank you all.